Good day, everybody, and we are once again back together looking at that DBE May-June 2021 paper. We're looking at question 8 as we've been actually doing during the course of this week, just looking at the different questions from question 1. So if you haven't caught those, please just go back and see as we've been reviewing each and every part of this paper. Right, for those of you who are still new to this channel, welcome. And the question is, where have you been, hey? Right, so if you haven't subscribed, please just make sure that you're part of the family, okay? And just hit that bell button so that you can, be notified every time that we're posting a new lesson. Okay, and by the way, for those of you who may need assistance with either mathematics or physical science, you're more than welcome to just get in touch with us, and our email address is info@mlungisi.co.za. All right, let's get into electrical circuits, probably one of my favorite sections. I'm kind of biased towards it, eh? Right, so they say 3 resistors are connected to a battery with an unknown EMF and an unknown internal resistance as shown. Right, they say ignore the effects, or rather the resistance of the connecting wires. Okay, they say in addition to the EMF of a battery given below, okay, A and B represents missing words or phrases. Oh goodness. They say the battery of the EMF of a battery, right, I don't know if I'm reading that correctly. It says the EMF of the battery is the maximum. All right, so A should be energy, right? Remember, that's the maximum energy per unit charge, right, passing through it. All right, just keep in mind that's the definition for EMF. Right, they say write down and B on your answer book and the missing words. All right, so remember, all you'll just write is A, obviously that would be energy, and B, that would be charge. Okay, so that's the maximum energy per unit charge. All right, they say with switch S closed, so when we close switch S, what's going to happen? It means that there will be current that flows through this resistor, the 7 ohm resistor here. Right, they say the voltmeter reads 2.63. Now, I want you to please note that so the voltage reading here would be the external voltage of the entire circuit. Okay, now if we look at this, we see what's happening. We're going to have current flowing through the circuit, the total current there. We get to this node, some of the current would go through the 4 and the 3 there. And obviously some of the current would go through that 7 ohm resistor. So it means the combination of these two is actually in parallel with the 7 ohm resistor there. Right, now they say switch S is now opened and the voltmeter reads 2.8 volts. Okay, now, no, actually I think I've skipped a question. They said calculate the equivalent external resistance of the circuit. Okay. So we're just looking at those resistors there. We said we've got these two in series with one another because the same current would pass across them. So let's start by saying, okay, so we're going to take our series, which is going to be R1 plus R2, okay, which is 4 plus 3, okay, which is 7 ohms. Now, what do you notice? We've got 7 ohm resistor being in parallel with that 7 ohm resistor. So R parallel, okay, I like that product over sum, formula. Product divided by the sum. Of course, where do we take this from? We take it from the formula that says 1 over R parallel is equals to 1 over R1 plus 1 over R2. Please don't be alarmed thinking that we are changing things, right? Okay, so when you actually simplify this, it actually works out to that. So we've got 7 multiplied by 7 divided by 7 plus 7, okay? And by the way, I just want you to note for the future, if you've got two resistors that are in parallel to each other, the effective resistance will actually be half one of them. So we know the effective resistance should actually be a half of 7, which is 3.5 ohms. Okay, right, so that's our equivalent resistance. So R external should actually be equal to 3.5 ohms. Right, so the next question, they say we should now calculate the internal resistance of the battery. Okay. Oh, and by the way, I just skipped another part again. They say switch S is now opened and the voltmeter now reads 2.8 volts. Of course, when you change the external resistance of your circuit, it will ultimately affect the external voltage, okay? Because what it does is that it will affect the current, first of all, the value of your current, and ultimately your V loss value, and it will ultimately affect your V external value. Okay, so we're gonna do this. We're gonna have to go the route of using a simultaneous equation. So let's say EMF. Let's start with the initial setup. Okay, so in the initial setup, we say E is equals to I into R plus small r, right? In fact, let's not even go this route because we don't even have the value of the current. So I'm going to say E is equals to V external plus V internal. Now, if you're not sure where we get this from, it means you haven't watched our series, or you haven't watched our playlist on Ohm's law. Please go back, look at that, and you'll see where we got this formula from. So we say, well, EMF is V external plus V internal. So in this case, I know I'm looking for, the internal resistance. Okay, so I'm just going to say, well, it means this is V external. So this, I'm going to base it on the first, V external value. So we're given this value to be 2.63 plus, but what is the internal voltage in this case? Plus I times small r. It seems like I can't escape having to find that current, isn't it? Okay, so we can find the current value in the initial setup. And what I'm going to do is say, well, what's our total current? It's going to be V external divided by R external, okay? And you remember V external were given to be 2.63, and our external resistance in this case, we had calculated it as 3.5, okay? So let's find that current there. So that's 2.63 divided by 3.5, and I get a value of 0.75. Okay, so I get a value of 0.75 amperes of current. That's my total current over there. Okay, so it means we could have actually just used that one as well. Okay, so E would be 2.63 plus 0.75 multiplied by R. Now obviously you can see we've got two unknowns there. I'm going to call this equation 1. All right, now let's do the same for the second setup, where they now open that switch. So the moment they open that switch, it means that this 7 ohm resistor goes away. My effective resistance now becomes 7 ohms. The 3 and the 4 and the 3 ohm resistors in series with each other. So we can find the total current for that setup now. So they told us that V external becomes 2.8. So that would be V external divided by the external resistance, which is 7. So there we get, so 2.8 divided by 7, that should give us 0.4. So we know our new current is 0.4 amperes. Can you see? now that we have changed, the setup, the external resistance, in this case it affects the current, which obviously will ultimately affect the lost volts, okay, or what we call V internal. Okay, so for equation 2, again we're going to use the same equation. Let's use V external plus V internal, okay, or V loss, okay, that's what I'm used to calling it. Okay, so in this case we still don't know the value of the EMF. Our V external value this time is 2.8, but the internal voltage, it's going to be 0.4 amperes, I times R multiplied by the internal resistance. Now I want you to please note, so let's call this equation 2. All right, please note that the internal resistance is the same for both setups, so is the EMF. So as a result, now because both of them represent EMF, so it means I can simply say equation 1 is actually equal to equation 2. I can equate the right hand side of each equation, right? So it means that 2.63 plus 0.75 R should be equal to 2.8 plus 0.4 R. Okay, let me just make sure that I don't mix those two up. All right, so all that's left is for us to do some gymnastics mathematically. All right, and let's find the final answer. Okay, ultimately I get a value of R. It's approximately 0.5 ohms. That's my internal resistance. Look, you can work it out and obviously try to get that answer. That's the answer that I get. And then they say now we should work out the EMF of the battery. All that's left for us to do, we can now take the value of R and substitute it into any of the two equations. Okay, so I'm going to do that. So for 8.3.2, we can just say substitute for R is 0.5 in equation, let's say in equation 2. Okay, and all that we simply do is say, well, E is 2.8 plus 0.4 times 0.5, and our EMF value, let's see, should be, okay, so 0.4 times 0.5 gives us 0.2, and if we add that to 2.8, we should get an EMF of 3 volts. Okay, so that is my EMF value. All right, so hopefully you were able to follow on in what I did there. And of course, you could have easily have used that equation as well, but all it would mean is that you'd have to find the external current in each of the two cases and ultimately just get that final answer. All right, I hope that was very helpful. As you prepare towards the exams, please, ladies and gents, don't let your guard down. Just make sure that you work as hard as possible. Despite what has happened in the previous exams, just keep pushing hard. There's more ahead of us, okay? Right, so please don't lose your cool. Be patient with yourself as you prepare, and just enjoy that physics, okay? Right, otherwise I'll see you guys next time. Please just remember to also let more people know about the help that you're getting from our channel. See you guys next time. Sharp sharp.